Yes, lasers is light amplification by stimulated emission of radiation. So what is laser is it's monochromatic, coherent and focused light, and it's highly intense beam of light. So how is laser produced is the main principle that we will discuss here. So before that we will discuss three important processes of light interaction with matter, that is induced absorption. First one, absorption means an atom will absorb the energy and go from lower level to higher level. So therefore we have taken here two energy levels in an atom, that is E1 and E2. The atom is in the ground level, let's say E1, and there is a light which is incident on the material, say of energy equal to h nu, and intensity is u nu. So when the atom absorbs this light, it will go from a lower level to higher level. Okay, so this process is known as the induced absorption. I can write it as atom plus h nu is equal to atom star. So the atom is in the ground state which absorbs the energy and it will go to excited state. In that excited state I write it as atom star. So now let me take the mathematical part behind this. That is, if I take the number of atoms which are available in the whole material in the ground level E1. So let us say that is N1 is the number of atoms which are in the ground level E1 per unit volume. Similarly in the energy level E2, let us say N to be the number of atoms in the energy level E2 per unit volume. So then I will talk about how many induced absorptions will take place in the material per second per unit volume. So that I call it as rate of induced absorption. The rate of induced absorption is proportional to how many number of atoms are available in the ground level N1. And it also depends upon the intensity of the light which is incident on the material. Right? The more is the intensity of the light falling, the more will be the number of induced absorptions. So therefore it is proportional to u nu. Therefore I can say it is proportional to the product of both N1 and u nu, or it's equal to a constant of proportionality B1 to N1 u nu. So another process we can talk about is the spontaneous emission. The spontaneous emission is the atom is already in the excited level and it will come down from upper level to the ground level on its own without being influenced by the external factor. So the atom comes from upper level to lower level with the emission of light. So this is known as the spontaneous emission. So I can represent it like this: atom in the excited state comes down to ground level with the emission of light h nu. So how many number of spontaneous emission will take place per second per unit volume? That I call it as the rate of spontaneous emission. So let us say there are again N1 number of atoms in the E1 and N2 number of atoms in the E2. Then rate of spontaneous emission is proportional to the number of atoms which are available in the higher level. So that is proportional to N2, or it is equal to A21 N2. Okay, so the constant of proportionality is called A21. So this is the Einstein coefficient for the spontaneous emission. These coefficients are nothing but the probability factor. What is the probability that this process will take place? So that is given by these coefficients B12 and A21.